Hello, I'm James, your digital avatar for SkillSpark. Have you ever heard terms like machine learning, neural networks, or LLM and felt a bit lost? You're in the right place. This is part 1, the foundations of AI. Over the next few videos, we are going to demystify these buzzwords and build a solid foundation of knowledge, step by step. By the end of this series, you'll understand exactly how AI works. Let's begin our journey and spark some new skills.
Hey everyone! So, artificial intelligence. It's a term you hear absolutely everywhere. But what does it actually mean? Well, over the next few minutes, we're going to cut through all the jargon and get right to the core of how AI really works. We're talking the big ideas, the essential concepts, and even some practical skills you can start using today. Ready? Let's dive in.
So, here's our game plan. First up, we'll tackle the big picture. Clearing up the confusion between AI, machine learning, and deep learning. Then we're going to get into how these things actually think and generate language. We'll even peek inside the AI's brain and then look at the two main ways they learn stuff. And to finish it all off, we'll get super practical and talk about how you can give an AI the best instructions to get what you want.
Okay, let's jump right into it. First things first, AI, machine learning, and deep learning. I know, you hear these words thrown around all the time, sometimes interchangeably. But here's the thing, they are not the same. Let's make this super clear.
So, what is artificial intelligence, really? It's the million-dollar question, right? When someone says AI, what pops into your head? Killer robots? A super intelligent computer from a movie? The truth is, it's kind of a bit of both. But the real answer is probably a lot simpler than you'd expect.
Probably the absolute best way to get your head around this is to think of Russian nesting dolls. You've got the biggest doll on the outside, right? That's artificial intelligence, the whole field. You open it up, and inside there's a smaller doll. That's machine learning. And then you open that one, and you find the smallest and honestly most powerful doll inside, deep learning. Each one fits neatly inside the other.
So that biggest doll, artificial intelligence, or AI for short, that's the umbrella term for everything. It's the whole grand idea, the entire scientific quest to build computers that can do things that usually require human smarts. We're talking about anything from playing a complex game of chess to understanding what we say.
Okay, let's crack open that big AI doll. What's inside? Machine learning. Now, this is where things get really cool. See, instead of a programmer sitting down and writing millions of lines of if-then rules, machine learning lets the computer, learn on its own. We just feed it tons and tons of data, and it starts to figure out the patterns and make predictions all by itself. Honestly, this is how most of the AI you interact with today actually functions.
And now for the final doll, the one tucked inside machine learning. This is deep learning. This is really the engine driving the whole AI revolution we're seeing right now. It's a special kind of machine learning that uses these really complex, layered structures called, you guessed it, artificial neural networks. The cool part? They're inspired by how our own brains are wired, and they're the reason AI can do mind-blowing stuff like identify a face in a photo or write an email that sounds just like a person.
Okay, so we've established that deep learning is the engine. Now let's pop the hood and look at a very specific, very famous part of that engine, large language models, or LLMs. These are the brains behind tools like ChatGPT. So, how in the world do they actually seem to think and talk back to us?
Look, if you remember just one thing about LLMs, make it this. At its heart, an LLM is basically the world's most powerful, most sophisticated autocomplete. Seriously, it's been fed a gigantic chunk of the internet, and its main goal, its entire purpose, is to guess what's the most likely word that comes next. So how does that actually work in practice? Let's say you type in the quick brown fox. The LLM looks at those words, analyzes the context, and thinks about all the connections it's learned from reading billions of sentences. Then it makes a statistical bet on the most probable next word, which is jumps. And then it just does that again and again and again, predicting one word at a time to build out whole sentences, paragraphs, you name it.
And that's it. That seemingly simple process of predicting the next word is how these tools can do all this incredible stuff. Write your emails, answer your weirdest questions, compose a poem, or even spit out working computer code. It feels like magic, but when you boil it all down, it's just really good autocomplete.
All right, so I've mentioned a couple of times now that deep learning uses these neural networks that are inspired by the human brain. But what does that actually mean? Let's take a look at how an AI's brain is really put together.
The analogy is actually pretty straightforward. Your brain has billions of biological neurons all connected together, right? Well, an artificial neural network basically copies that idea. Instead of neurons, it has digital nodes. And just like in our brain, these nodes are organized in layers and are all interconnected.
So let's follow a piece of data on its journey through this network. First, it comes in through the input layer. Then it travels through one or more hidden layers. In these middle layers, each little node does a tiny calculation, tweaking the information just a bit before passing it along. As the data zips through all these layers, the network gets better and better at spotting complex patterns. And finally, you get to the output layer, which spits out the final answer, whether that's a prediction, a decision, or a piece of text.
So why should you care about any of this? Well, because these neural networks are the unsung heroes of your digital life. They're the magic that lets your phone automatically tag your friends in photos. They're what power the recommendation engine that somehow knows exactly what movie you want to watch next. They are working behind the scenes all the time in so many apps you use every single day.
Okay, so we have the brain, the neural network. But how does it actually learn anything? Well, in machine learning, there are two main schools of thought, two main ways of teaching an AI, supervised and unsupervised learning.
And honestly, a couple of simple analogies make the difference pretty obvious. Think of supervised learning like teaching a toddler with flashcards. You show them a picture of a cat, and you say, cat. You show them a dog, you say dog. You're giving it labeled examples. Now, unsupervised learning is more like handing that toddler a big box of Legos and saying, go sort these. They'll start making piles of red ones, blue ones, big ones, small ones. They're finding the patterns all on their own, without you telling them the rules.
And here you can see exactly what that looks like. On one side, you have supervised learning. We're literally feeding the AI thousands of pictures that are already labeled cat or dog. It's like a digital flashcard session. On the other side, you have unsupervised learning. We've just dumped a bin of mixed up parts in front of the AI, and its job is to figure out for itself how to group the similar pieces together.
All right, we've covered a ton of theory, the what and the how. So for this last part, let's bring it back to you. Let's get practical. Because here's the secret. Getting amazing results out of an AI isn't about the AI, it's about you and the instructions you give it. This is what people are calling prompt engineering.
So what is a prompt? It's just a fancy word for the instructions you type into the chat box. It's your side of the conversation with the AI. But here's the most important takeaway. The quality of the answer you get back is almost 100% dependent on the quality of the prompt you write. You are completely in the driver's seat.
Let me show you a quick example of a bad prompt versus a good one. A bad prompt is something vague, like, tell me about AI. The AI has no idea what you really want, so it'll just give you a boring generic definition. But a good prompt gets specific, something like, provide a brief history of AI, but focus on the key milestones from the 1950s up to today. See the difference? You've given it a topic, a scope, and a timeline. Now it knows exactly what to do.
So, what are the ingredients of a great prompt? It really boils down to four things. First, clarity. Just be super clear and easy to understand. Second, context. Give it a little background info. Third, specificity. Really narrow down what you're asking for. And finally, constraints. Tell it what you want the output to look like. Do you want a 3-paragraph summary, a bulleted list, an answer written like a pirate? You tell it. If you can nail these four things, I promise, the quality of your AI results will skyrocket.
And there you have it. That was a super quick tour, but now you've got the building blocks. From the big ideas like AI and neural networks, right down to the practical skill of writing a good prompt, you now have a real foundation for understanding how this stuff works, and more importantly, how to start using it yourself.
So, you get the basic concepts now, and you know how to talk to it. The only question left is, what are you going to do with it? Seriously, you can ask it to help you write a story, plan a trip, debug some code, even come up with a business idea. The power is literally there at your fingertips. So go on. What will you create?
You've just taken the first step to truly understanding AI. In our next video, we'll explore AI agents, the AIs that can take action for you. If this video sparked an aha moment, please like and subscribe to SkillSpark. What surprised you most today? Let me know in the comments. I'm James, reminding you to keep sparking new skills. See you next time. Bye.